Some 1,700 years ago, Greek astronomer and geographer Ptolemy chose to count longitude from the Fortunate Islands, which were probably the Canaries, the farthest point west known to the Greeks. His maps were the first to depict a spherical world. They showed longitude ranging from 0 to 180 degrees, with 0 at the Fortunate Islands and 180 near the east coast of China. His world map was the first known to put coordinates on a plane. But it wouldn't be until the 15th century before Ptolemy's maps were widely published and used by the navigators Amerigo Vespucci, Magellan, and Columbus. But before this time of exploration began, Europe would move in a totally different direction. The Crusades brought Christian Europe into conflict with the Islamic world. These wars over the Holy Land closed most land routes to Asia, which became a huge problem for European merchants. Stories about the advanced civilizations in Asia from Marco Polo and other travelers had created a sensation and a large and lucrative market for their exotic goods. So rich European merchants desperately needed another trade route to Asia. This desperation led to an unconventional answer, the possibility of a sea route west. Like the early Greeks, educated Europeans of the Middle Ages knew the world was round and sailing west would lead to Asia. The problem was navigation, finding your way in the vast open ocean. But they knew that math held the solution. Mathematical works from ancient Greece, India, and China, translated and built upon by the Moors, were brought back home from Moorish schools by European scholars. These works revealed many things, including a method the Muslims had for determining longitude using astronomy. They knew the Earth turns 360 degrees in 24 hours, 15 degrees in 1 hour, or 1 degree in 4 minutes. So if two observers saw the same celestial event, say a lunar eclipse, and in one location it happened at 10 minutes after midnight, while at the other it happened 30 minutes before midnight, they knew the difference in longitude was 40 minutes, or 10 degrees. The only tool required was a clock that kept decent time and a way for the two observers to eventually communicate their observations. This worked fairly well on land, but not at sea, because no clock could keep accurate time on a moving ship. It was a problem that would not be solved for centuries, but that didn't stop Europeans from trying. By 1400, new ideas were beginning to take hold, ideas based on reason, observation, and math. And for the first time in ages, Europeans could see just over the horizon a bright new world.